Can you see my screen or hear me?
Here we can hear and even can see. Yeah, it's right presentations. You can start.
So one more presentation from me about towards safe and sustainable agricultural reconstruction in Ukraine, insights from satellite-based crops classification maps. So our team more or less the same, but we have one more representatives from the World Bank and the European Commission. So here is also quick content and motivation. Ukraine, as you know, has a long key player in the global agricultural market, but the ongoing war has severely impacted its agricultural sector. And this has not only affected Ukraine, but also contributed to global food security issues. And monitoring land use changes is crucial for guiding post-war reconstruction efforts, particularly in agriculture. However, global land cover products often lack the crop-specific details needed for precise monitoring. And recent advances in satellite data, particularly from Sentinel-1 and Sentinel-2, allow us to overcome this limitation and generate accurate crop classification maps. So our research aimed to, first of all, review the existing global crop maps for Ukraine, to compare the accuracy of various products using ground truth dataset, which we collected within World Bank project and within other projects, to analyze land use change patterns and land use change, particularly in the context of the ongoing war. So we reviewed various global land cover data sets, such as Copernicus global land cover and MODIS land cover type and other ones. And we see that they have not very big spatial resolution, and two more products that have also 10 meters resolution. It is a world cover, but they are available just for 2 years, and there is no specific crop types division. And one more product is World Cereal product within this project. They also have 10-meter spatial resolution. It is free available just for 1 year, and they have deviation into two types of crops. It's just cereal and maize. And our product that we propose, KPI Ukraine, focuses on specific crops like wheat, barley, maize, rapeseed, and sunflower, and another one with a high spatial resolution. And these products covering the period from 2016 to 2024. We use machine learning model in the cloud to generate these classification maps. Sentinel-1 provides 12 days composites, and Sentinel-2 delivers monthly composite for analysis. And ground data collected annually along the road, it divided into training and testing sets to create and validate the accuracy of our product. In general, we have used random forest classification in Google Earth Engine cloud platform, as Volodymyr said, and multi-layer perceptron in Creodios cloud platform. The in-situ data collection followed the JCOM guidelines for cropland and crop type definition and field data collection, and has been conducted since 2016. This slide illustrates the routes for collecting our data set for each year. And these routes were designed to cover the entire of Ukraine and ensuring a representative sample of the country's agricultural landscape. And however, after the 2022, the length of the roads and the number of collected samples decreased slightly due to access limitation and safety concern in a certain region. This data is used to train our models, ensuring the accuracy and reliability of the classification maps. So here we present the classification results for various land cover and crop type map in Ukraine for example, 2023. As you can see, the F1 score accuracy for bigger one is more than 19%. And also this year we have added a new class. As I said on my previous presentation, it was abounded not this year, since 2022 we have a new class, abandoned lands due to the war. And we have been producing annual land cover and crop type maps since 2016, offering detailed insights into the spatial distribution of crops in Ukraine. And these maps are a powerful tool for agricultural monitoring and reconstruction planning. And here you can see the comparison of the accuracy of our products. Our products have name Copy Ukraine, and with global products such all that we analyzed. And as you can see, our maps consistently maintain high accuracy and provide more detailed crop-specific information compared to other global products. And the total cropland area, what we can say about area, remained relatively stable before the war, with a slight increase observed up to 2021. And however, after the onset of the full-scale invasion in 2022, significant differences between 2021 and 2022 and 2021 and 2023 reveal a substantial decline in cropland area in regions that impacted by the war, such as Khersonska, Donetska, Luganska, and Zaporizhzhia. And for example, the Khersonska region saw more than 700,000 hectares. It is 44% of all of cropland area within this oblast. Yes, and if you will see the trend, the cropland area since 2016 to 2023 shows a stable trend with a slight increase until 2021, and followed by a sharp decline in 2022 and 2023, reflecting in the impact of the war. And at the same time, the trends in, for example, sunflower crop area from 2016 to 2023 show a consistent area under sunflower cultivation until 2021, and followed by a marked decline in occupied areas and an increase in region controlled by Ukraine post 2021. And this result highlights the impact of the full-scale invasion in Ukraine's agricultural sector, and showing a significant reductions in cultivated area, and especially in regions that directly affected by the war. And in conclusion, I would like to say that our methodology provides highly accurate crop-specific classification maps for Ukraine, essential for agricultural monitoring and post-war reconstruction. Compared to global and cover products, our maps deliver greater detail and crop-specific information, and future research will focus on improving our methodology, maybe using more data sources and exploring real-time monitoring for repeat decision-making in this case. And we would like to acknowledge the support from the Joint Research Center, European Commission, World Bank, as well as National Research Foundation of Ukraine and the Ministry of Education and Science of Ukraine. Thank you for your attention. Maybe you have some questions.
Questions, dear colleagues, be active and proactive. I have some questions. It's very interesting for me. I'm very interested in this. You mentioned that you plan to improve your technology, but it looks like an ideal solution. What do you mean?
It looks like ideal, but we understand that, for example, you said with Volodymyr that, for example, Google Earth Engine platform have some limitations, yes. So we need to think about it and to use some maybe algorithm that will work quickly and to give best results in another cloud platform, for example, CreoDS.
Some not strange, but just question. Is it possible to improve the accuracy? Or what you have now, it's enough and good? And
I think it's possible to improve the accuracy from minor crops. If we will have some training data, we can improve such accuracy, but not for major crops.
So will it be enough Sentinel? I think no. What do you think? It depends. It's future plans.
We need uh, to to have some study about it.
Yeah. Yeah. Okay. Thank you very much. Maybe other questions. Yeah, thank you. Thank you again. It was great. So we have last presentations about